Imagine this. You build a beautiful website or web app, maybe a blog, a student dashboard, or an online store. It works smoothly until one day, someone injects a single line of code, and suddenly, all your data is exposed. That's the high-stakes world of web application security. In this lesson, you learn how websites get hacked, what hackers look for, and how developers and testers can defend against these digital break-ins. We'll walk through key vulnerabilities, essential protection principles, and even practice spotting dangerous code. By the end, you'll be thinking like a hacker and building like a security pro. Think of a web application like an open shop on a busy street. The doors never close. People are always coming in, browsing, interacting. But behind that convenience lies constant risk. Web application security is all about protecting what powers that experience, the data, the logic, and the users from being misused. Since your app is always online, every feature you offer, from login pages to file uploads, becomes an opportunity for attackers to sneak in. That's why forms, comment boxes, and even search bars must be treated with caution. You're not just building functionality, you're building a digital fortress. Hackers don't need to break through your front door. They look for unlocked windows. To understand how to defend your application, you need to think like an attacker. Login forms are tempting. People reuse passwords, and brute force tools guess fast. Search bars and inputs can be exploited with sneaky code like SQL or JavaScript injections. Upload fields? Perfect for hiding malware. APIs, often overlooked, can leak sensitive data if tokens aren't protected. Even the humble, forgot password feature can be twisted to hijack accounts. And those fancy plugins or third-party scripts, they might bring more than you bargained for. The best defense is a smart design. Let's walk through 6 foundational principles that guide secure web development. First, least privilege means no one gets more access than they need, not even admins. Next, input validation. Always assume user input is suspicious until proven safe. Then there's authentication and authorization. These control who gets in and what they can do. Secure sessions means your tokens and cookies must be protected, not exposed. Error handling should be silent to outsiders. Don't reveal internal errors that hackers can use. Finally, data encryption ensures your info stays safe in transit and when stored. Let's explore the battlefield, the actual attacks developers must defend against. SQL injection allows hackers to send rogue queries into your database. XSS, or cross-site scripting, lets them run malicious scripts right inside someone's browser. CSRF, or cross-site request forgery, tricks users into performing dangerous actions without knowing. Broken authentication makes logins vulnerable to hijack. Directory traversal is like breaking into locked drawers on your server. To really grasp these, try labs like DPDPA, Juice Shop, or TryHackMe. They're safe places to simulate the chaos. Understanding these threats transforms you from passive builder to active guardian. Here's your essential armor, a quick, high-impact checklist every secure web app should follow. First, always use HTTPS to encrypt data in transit. Sanitize every user input. Don't trust anything coming from outside. Set strict security headers to prevent malicious scripts. Store passwords using salted hashing like BCRYPT, never in plain text. Use robust authentication, not just passwords, but multi-factor when possible. And don't forget rate limiting and CAPTCHA to stop brute force attacks. These steps may seem basic, but they're often missed, and every one of them blocks a common path for attackers. Let's shift from theory to practice. I'll show you a piece of insecure code. Your task is to think like an attacker. What would they try injecting? Is the input unchecked? Is the session easily hijacked? Then, switch hats. Suggest how to fix it using the principles we covered. This mini exercise helps you develop security intuition, that ability to spot weak links before they break. Remember, great developers aren't just builders, they're guardians of trust. This practice sharpens your mindset for real-world work. Challenge 1. A login form has a hard-coded admin password, just 1234. What's unsafe here? Could someone try brute force or credential stuffing to break in? Take a moment to think. Answer: hard-coded weak passwords are vulnerable to brute force attacks. Fix it by enforcing strong passwords, rate limiting, account lockouts, and multi-factor authentication. Challenge 2. The search bar takes user input and plugs it straight into an SQL query. What if a hacker types % or 1 is equal to 1? What could go wrong here? Answer: this is classic SQL injection. The fix is to use prepared statements or parameterized queries and always sanitize user inputs. Challenge 3. The search results page directly shows the user's input, like results for user input. What happens if someone types in script alert, hacked script? Think about it. Answer: this is cross-site scripting or XSS. Always escape output and use frameworks that auto-escape HTML to protect users. Challenge 4. The app lets users upload any file, even a.php shell. What could an attacker do with this? Answer: they could upload malware or execute remote code. The fix is to restrict file types, scan uploads for malicious content, and store files outside the web root. Challenge 5. The API uses a token directly in front-end JavaScript, visible to anyone in DevTools. What's the risk here? Answer: token theft. Attackers could steal or replay API requests, store tokens securely in HTTP-only cookies or secret managers, and rotate keys regularly. Challenge 6. Password reset links never expire, like reset.php, token is equal to appdef12345. What could go wrong if someone intercepts or shares this link? Answer: this can lead to account takeover. Always make reset links expire quickly, use one-time tokens, and revoke after reset. Challenge 7. A critical script is loaded from an unknown external source, like cdn.unknownsource.com. What's the danger here? Answer: this is dependency hijacking. An attacker could inject malicious code and steal data. Fix it by using trusted CDNs, sub-resource integrity checks, or self-hosting critical scripts. That's it. You've just practiced spotting vulnerabilities in login forms, search inputs, uploads, APIs, password resets, and third-party scripts. Every line of code you write can either be a door for attackers or a shield for your users. You've just taken your first step into the powerful world of web application security. You now understand how attackers think, where apps break down, and how smart design principles prevent disaster. You've practiced spotting dangerous code and started thinking with a security-first mindset. This isn't just about websites, it's about protecting real people and real data. Whether you're a developer, tester, or curious learner, this knowledge gives you an edge in a digital world full of threats. Stay curious, keep learning, and remember, every secure app starts with someone who cared enough to defend it.